Hey everybody. Uh, there's a new paper from Daniel Archer out. Thank you for writing this, Daniel. Uh, it's absolutely fantastic that the theory can continue on without me writing papers because, well, I'm lazy. So, of course, Celeste and I both agree that it shouldn't be just me discussing the theory. A lot of people should be working on it, and I guess just my stance is just to provide a little bit of guidance here and there, and just sort of to take back and get a little breather in and just watch everything go down from distance. That way I don't get too involved and I can focus on other things. Uh, but this paper, stellar metamorphosis, gas giants evolve into gas dwarfs. I'm not going to take the steam out of this paper. I'll link it to the bottom. It definitely it goes over a few things as to why gas giants evolve into gas dwarfs, as Daniel calls them. Of course, Daniel keeps with the main meat of the theory, and that these objects are all evolutionary structures that evolve over time. So any approach towards it, any theory that strives to explain this process in depth is definitely the future of astrophysics, the future of geophysics, and the future of chemistry, and of, well, basically life science and every science out there. It's the most encompassing theory that I can think of at the moment. And if you want to write a paper on it, whoever you may be, do so on Vixra. Of course, get some reference in there, make it a little professional looking. The new moderators of Vixra like papers that look professional, I guess, to academic norms is what they say, whatever that means. I don't want to read this paper off. There's just one thing. If Daniel is watching this, one thing I want people to notice too, and Daniel as well. The temperatures of these objects, the temperatures of the objects, they're always looking at the outer edges of it, the very top of the ball. Like if you're a basketball, it's the pleated, it's the abrasive area on top, and then the astronomers go, well, that's where the temperature is. The temperature of a star isn't just its surface. The temperature is something that can be measured throughout the entire depth of the star itself. And the temperatures change as they evolve internally and externally and near the surface. So it's an incredibly complex process that temperatures do change. And strictly from an observational stance, looking directly at it with a telescope, of course, you measure the temperature of the outer regions. But it's also very wise to remember that the interior regions are extraordinarily hot. And those temperatures are very different for what star you have in question. So even if the temperature is 125 Kelvin near the surface, it's wise to go, well, that's just the surface temperature. Because if it's evolving and crushing itself, the internal temperature is insanely high. I think I remember reading an article where they had mentioned that Jupiter currently has an internal temperature where the core is forming currently of 35,000 Kelvin. And that's extremely hot. But you wouldn't really consider that with the astronomers only looking at the surface going, oh, it's a cold object. And then they look at Neptune and Uranus as being cold as well. The ice giants, they're just ices. They're extremely hot in their interiors, tens of thousands of degrees Kelvin, because they're crushing themselves as they evolve, and their atmospheres are lost, and they evolve into something more Earth-like over time. But anyways, that basically, I'll link this to the bottom. I don't want to read it because it'll take the steam away from Daniel. A few other ideas I want to discuss real quick. Hopefully, Pierre-Marie Robitaille discusses this discovery in light that stellar evolution is planet formation. I highly doubt that he's going to discuss it in those terms, but let's see what happens, especially with regards to water formation, because young stars have lots of oxygen and they have lots of hydrogen. And as they evolve, those two elements combine together, making water. And that water does facilitate other reactions to take place. Of course, other reactions lead to the byproduct of water. So it's best to look at stars as giant chemical furnaces, not the fusion pseudoscience of the 1950s. But I guess that sums up this talk. Okay, I don't know if I said hi Celeste, but hi Celeste. And I'm looking forward to seeing another Sky Scholar video on that note, as well as the demystifying science people. I'm actually curious to see what they produce as well. Things are starting to speed up a little bit, and people are starting to wake up to the Big Bang and dark matter nonsense en masse. So it should be interesting to see what happens in the next couple of years. All right, later, y'all.